Let the record show Tyler enjoyed his sandwich. All right. We're going to learn how to use Git, which is a version control tool. A little bit of background terminology. Git is, if you read the man page for Git, at the very top, it'll say Git is the stupid content tracker. Git was written by Linus Torvalds, who's the person who wrote Linux. There's a big long history about why Git was written. But basically, version control is something that allows a user to make copies or back up their source code, but not just do like our backup script, right? We don't like, okay, today I've got source code that works. Like we've got a set of scripts that we wrote for homework on Friday. They work. I'm going to make a backup of those so that if I try to edit them, I don't accidentally break them, right? And so a version control system is basically that, but it's more advanced. So it allows you to do things like go back to previous versions, take versions that multiple people have worked on and merge them together. I mean, it's a very sophisticated system for allowing collaboration and keeping backups of your source code. So Git was written by Linus Torvalds because the version control system that they were using was, I don't know what the deal was, something about the license was getting, it wasn't completely free. They had sort of a license from the company that allowed them to use it for free, but the company was going to take away that license, something like this. And so Linus basically sat down and wrote Git in like 2 weeks and then switched the entire Linux kernel, which is all of the source code that goes into the Linux kernel, over to Git. So for us right now as single users, it's still going to be fairly useful because it'll allow you to keep a complete history of your project. You can sort of keep a documented timeline of what changes you made and when, and then you can always roll back and get to old versions. And then for multiple users, it's very useful because it allows multiple people to work together. So if Patrick and I decide we want to work on a program together, we're going to write code to do something. I don't know. What are you writing code to do, Patrick? What's one of your projects?
All sorts of projects.
All right, let's.
Thermometer.
Oh yeah, all right. So that one I could get on with. So to automate the collection of temperatures from remote positions, right? So I decided I'm going to help Patrick. We would use Git to collaborate on that, so that when I'm making changes and he makes changes, Git can tell us how to merge those changes. Why do we care? Well, it's become very popular since 2005. If you've heard of GitHub, GitHub is a website that's built on the Git version control program. This is another one of those things that's, you know, having experience using Git is going to be similar to having experience using LaTeX, having experience using Bash scripts, having experience using the Linux command line. It's a tool that's very popular. It's very common. If you can put on your resume that you know how to use this, then there are several places when you're applying for a job that can say, well, look, this person already knows how to use the version control system that we're using. So they'll fit right in. It's a good skill to have. It's also a good thing to do. So typically the reason that you don't use a version control system is because it's a pain to get set up, or you haven't taken the time to learn how to use one. And that ends up leading to, like what happened to Gavin, almost losing a dissertation, right? If he was using Git, he would have had it backed up. It would have been backed up at multiple locations. He wouldn't have been afraid of losing his dissertation because he accidentally deleted everything in the directory. So just a little bit of terminology in terms of the types of things that we're going to be talking about. Yes, Derek.
Is Git like an application like how that GNU-Plot is, or is it like a command?
It's a command. So it doesn't open up and you don't type in commands that it interprets like GNU-Plot. It's a command that you run at the command line, and it does things like create a snapshot, or print out the history of your repository, or add files to the stage, stuff like that. So a snapshot is a copy of a directory at an instant in time. The backup scripts that we wrote take snapshots of a directory. That's just making a copy of the directory at that instant in time. If you make multiple copies of the directory, then you might want to have some way of telling them apart, right? So if you have multiple snapshots, you'd start to version those snapshots. So This is a snapshot that I took Friday, March, I better not show, let's just say March 3rd at 2:30 in the afternoon, right? And the backup scripts that you wrote, time-stamped it so that you'd have a version associated with it. History would be a collection of all of the versions that a file goes through. So if I have a file that I change, make a snapshot, make a change, take a snapshot, make a change, take a snapshot. The history for that file is considered what did that file look like at every snapshot that was taken. So we can talk about the history of files or directories, and Git allows us to track all of that. A repository is the name used to, basically it's where the history and the snapshots for a directory are stored. So a Git repository is something that contains all of the history for all of the files that you have in a given directory. A commit is when you take a specific snapshot. So you say, okay, I want to make a snapshot right now. What you do is commit that snapshot to the repository. Before you commit it to the repository, it can still be lost. After you commit it to the repository, it can be pulled out of the repository. Merge is something that's going to come up if you make changes on separate, if multiple people make the same changes to the same file, or if on multiple branches. We'll see more of that later on. And a patch is something that is sort of a programming thing. I mean, you've probably heard of security patches that get released. Basically, if I have a file, a version of a file that I know existed at a given time, I have a new version of a file. I can look at the differences between those files and create a patch that will turn any old version into the new version. So that I can send that patch to somebody and then they can apply it to their old version to produce the new version. Yes, Tyler?
So this is all held on our disk. So say we drop our laptop and mess our disk up, we can't retrieve that.
That's right. So the standard workflow when you're using Git is to have a remote repository set up somewhere, and it is trivial to push all of your changes and your commits to the remote repository. So then it is backed up offsite, not on your disk. And so it's very common to, yes, but the nice thing about it being on your disk is that if you go somewhere that doesn't have internet or you don't have access to the internet, you can still use the repository exactly as you would normally, even if you had internet connection.
GitHub's free for students.
What's that?
I think that GitHub's free for students for 2 years or something like that.
Oh, GitHub's free for everybody. I think that if you want to put commercial code on there, you might have to pay for it. But
Or private repos.
yeah, actually, I think you get private repos with the free account now too. I think. So the primary purpose of Git is to keep track of source code, right? It's basically made by a programmer who wants to write programs, and so it's designed to be used as a source code tracker. This is an example of one of those things that if the people that write the tool use the tool all the time, then the tool is going to get really good, because somebody who needs to keep track of their source code and uses Git, hundreds of times a day is not going to put up with things that are annoying. So they're going to make it good. They're going to get the bugs cleaned out. And so Git's really good at what it does. You write your program, you make improvements. You don't have to worry about losing work that you did. You don't have to do I better make a copy of this so that I can, before I start making these changes, because if these changes break my script, I want to have something that I can turn in for homework on Friday. Git sort of alleviates that. One of the side effects is that Git, there's nothing about the way Git is designed that only makes it useful for source code. You can keep track of anything. And I have like directories full of PDFs that I use Git to keep track of, right? So like my citation database is under Git repository. LaTeX is basically source code. So all of my LaTeX documents usually have a Git repository that I use to track them. So as you start writing more and more sections, you can keep snapshots and a history of what was going on. So really, it's not that you can only use this to track source code. It's absolutely trivial to take a directory that is on your system and say, I'm going to start making backups of this with Git, and then start doing that. All right, so let's check to see if it's installed. Type Git at the command line. If it says it's not installed, it'll tell you how to install it. So go ahead and install it. I don't know if it comes installed by default on these Linux Mint machines or not.
No.
No?
So apt get.
Apt get, yeah. What's Corey studying for something?
Mm-hmm.
Students of chemistry.
Do not miss those days. All right, let me briefly go through the basic Git commands that we're going to need, and then I've got a demo that we can follow along with. So to make a repository, plus you're out of a directory, all you have to do is go to the directory that you want to start tracking and type git init. That basically initializes an empty Git repository. It's really nice. You do not have to plan for something to be tracked with Git before you create the directory and start adding files. At any time you can come along, you can do a git init. Now what that's going to do is it's going to create a .git directory in there. So that's going to be hidden. So whenever you type ls, you won't see it, but it's going to be in there. And it's going to store all of that information, the repository information in there. The other nice thing is that to remove version control from the directory or to start over, all you have to do is delete that directory. Everything is in that directory. So you do not have to worry about, any sort of, registry getting written somewhere else on the system that keeps track of all of your repositories. Everything is local to that directory. Yes, Derek?
So sudo apt install git.
Uh-huh.
Apt install Git.
Apt install git.
I think that'll work.
Yeah.
Apt get install git. That's what you're wanting. But apt without anything else will work. Did that work?
Yeah.
Okay.
Git.
Git has something that was at the time when it was created was a little bit strange. Basically, you have to explicitly say you want to add stuff to the repository. And to do that, you use the git add command. And if you use a dot, that means current working directory. Git will recursively go through any directories that are given as arguments to the add command and add files that have changed or files that are new. And so typically what you're going to do is a git add dot. That puts the stuff in the stage, which is then ready to be put into the repository, but nothing's done until you actually commit it. You can always check to see what the status is, like what files are not in the repository, what files have changed, what files are staged to go into the repository with the git status command. This is one that we'll use a lot. It'll be like ls to just kind of see what the directory, what working tree looks like. And then finally you use a git commit to actually take the stuff and put it into the repository. All right. So, hold on. I should have had that talking the whole time. I had it in auto mode. I want to.
Now you can have your all your code set appear on the screen. Use eSpeak to say all of those.
Yeah, just to say what's coming over the screen as it's doing it. 01. I want to turn interactive mode on. Let's also make this bigger before I start it again. And run. All right, what I suggest you do, if you haven't done so yet, is to make a directory in your home directory called code. So I'm going to go to my home directory, and I'm going to create a directory called code. What's your naming convention?
All I have is code on this computer.
Oh, good.
So
So your home directory is your
kind of
code directory.
redundant.
All right, so mine already exists, but go ahead and create one if you haven't. And then let's go into the code directory and let's create a new directory called CL utils for command line utils. We're going to collect sort of the scripts that we've been using that do things like calculate averages, standard deviations, the stuff that we've been writing over the last several weeks. So I'm going to create that directory and then I'm going to go into that directory. Joey?
Yeah.
Good?
Yeah.
You're my pace car.
Okay.
I know if you're there, everybody who wants to be here is here. All right, so let's open up just a simple program. Let's create a little simple one just to have something to do. Let's use VI. Might as well. But we do not.
What's wrong with me?
All right, I'm going to add the shebang, which is /user/bin/python. And tell it to print hello world. So I'm in insert mode. To get out of insert mode, I need to hit escape. And then to save, I would enter the commands W, and then to quit, it would be a Q. So I'm gonna go to insert mode, and then down here at the bottom, you see it popped up, :WQ, that's gonna write, which means save, and then quit.
Which I checked just last class period. If you do QW, it'll say that it's an erroneous command and it won't run it.
Okay,
So you don't have to worry about accidentally quitting without saving.
that's nice, unless you do QW and then don't actually get the W hit Q. Actually, then it says that you need to save.
Yeah, you have to give it an exclamation point to quit without saving.
Which I mean,
I
it's
checked
a
that
line
as
there,
well.
so
I
it's-
think I'm
Yeah,
ready
it's-
to test out.
Yeah. All right, let's change mod to hello.py. Run it. Okay, it works. All right, so now let's do some Git stuff. I need to initialize my Git repository first. Git is the name of the command, but then we talk about Git commands. So the Git command is, Git is a program that takes essentially subcommands. And so this is the init command for Git. So we call that the Git command init.
Get in it.
Git init.
Get in it.
Get in it. Like initialize. Get in it.
I think we got it.
It's INIT after the command git. However it is you want to pronounce that.
Get is spelled with an I, and it's messing me up.
Every time it's spelled with an E.
Get used to it. Initialized, empty Git repository in, and see, it tells me that it's a .git. If I ran ls, I don't see it, but if I run ls tac a, it's right there. ls tac l tac a, ls tac a dot git, I see the stuff that's in that repository. So this is all plain, some of this stuff's not plain text, it's encoded in binary, but it's all just plain file system stuff. It's not like the Git repository is a single proprietary file format that there's no way you can figure out what's inside of there. It's just a directory that contains files that have information about the repository. All right, so let's run git status. Git status will tell us what the status of a repository is. It says it's on branch master. There hasn't been a commit yet, so it's saying that the initial commit is still to come. And then it lists out the untracked files. So hello.py is one that is not tracked. That means that the repository is not going to save that in a snapshot by default. We have to tell it that we want that to happen. And it actually tells us what to do. We can say git add and then the name of the file to add it to the list of things that will be committed. So let's add it. The most common use of the add command is going to be to just do a git add period. So that says add this directory, and then if you add directories, the files and directories underneath that directory get added recursively. So this will add everything. So you wouldn't use this if you had two files that were changed and you didn't actually want to add both of them at the same time. You wanted to add one, commit it, add another, commit it. But for most of the commits that we do, this is going to be perfectly fine. And then I'm going to run git status again just to make sure that it actually did get added to the stage. And it should show up as green now. So now it says changes to be committed. It also tells me how to remove that if I wanted to if I accidentally added something that I didn't really want to stage. And then git commit. We'll commit these changes.
Mine yells at me and tells me that I need to get the,
Oh,
that.
so we need to configure our username and password. And it tells us what we need to do here, right? So it's git, there's a config command, global, user.email, and user.name. All right, so let's do that. Git config global, user.email. I'm going to use my Fort Hays email address. If you don't want it in there, just make it blank. This is information that gets put into the history so that you can see who made specific changes to files whenever you go look through the repository history.
Oh, so it doesn't email it to you?
No.
Oh, it's one of these.
I'm sure we could set up a hook that would do that.
A hook?
Something that a script that automatically runs whenever you commit to the repository. So there's my email address, and then I'm going to use my name here, Steve Clark III. So I've got those added, and now it shouldn't complain when I try to do a git commit. You could put in your alias here if you for your username. Like Dinkle Little Star, for example, or JT Carr.
Little Star's not long enough. It's Dingle Dingle Little Star.
It's got to be 2 Dinkles. I know. We got to
Yeah.
change that. All right, now I do a git commit. Now, depending on how your system is set up, like mine opens up a VI text editor. This is the commit message. This is where you basically give a little piece of information, a little blurb that says what this commit is, like what changed. Now, there's the top line is it should be a short one that will be displayed on summaries, but then you can fill this file up with information. If you need to put a lot of information in there to make it clear what happened during this commit, then you can do that. But typically I only use the top line for my commit messages.
But it's kind of like patch notes.
Yeah. Yeah. And you guys, is yours opening up in VI or Nano? Nano.
Because
So there's
Recognize is the good one.
What's that?
Actually, because it recognizes.
Oh yeah. There's a way, I mean, I've changed my default editor on my system. There's an environment variable called editor, all caps. Remember how we changed the path variable in the bash RC script? You can do the same thing with editor and tell it to use VI instead if you wanted. Yeah.
What's the difference between the basic one and tiny?
Didn't we cover this?
Probably.
I think it's on the last video.
Yeah, the Vim Tiny is basically as little.
Stripped down as few features as it probably doesn't contain any of the plugins that would normally come
Cuts
with
all
it.
the fun parts out. Just leaves the bare bones.
So it still has your VI, your key bindings, which is nice. So for the first one, initial import is perfectly fine. That's sort of the standard commit message to use, initial import.
It does.
Init, EI, yeah, I think that's right.
Yeah, it is. The word just looks weird.
It's just a funny looking word. But if we say it 10 times fast, it sounds funny too. All right, I'm gonna write this and I'm gonna quit. Once I quit, the commit message is saved, the commit is made, that message is attached to that commit. If I, for some reason, ran git commit and then realized, oh crap, I don't have everything in here that I need, all you have to do is leave that file blank. So just delete that first line and close it, and it will abort the commit. So you can always change it and do it again.
So where has it now stored that file?
That is in the .git repository. Now everything here is the same as before. Right, still there. All you've done is taken a snapshot, and then Git does all of the work to put it into the repository so that it could be retrieved later if we wanted to.
How do we go about doing that?
Now, we're going to find out.
Stay tuned.
That's right. Stay tuned. We're going to see how we can go through commit by commit and see all the changes that have been made. We're going to see what happens when we delete files. Oh, it's going to be great. All right, let's run git status to see what happens. Basically, it says on branch master, nothing to commit, working directory is clean. So the working directory is the directory that you're actually in there working on. That's all the files that are on your, in this directory. The working directory is clean when the files that are in the working directory exactly match the last snapshot that was made, right? So right now, the way it is now, we have that in the repository. If I start making changes to these files, I will start seeing a unclean working directory with changes that I can commit. All right, so let's open up the hello world.py file and make some changes. So I'm just going to capitalize hello and world now. So now this file is different than it was before. Save these changes, close the file. If I run git status, it tells me changes not staged for commit. And this time it doesn't say untracked file, it says modified. So it knows about this file and it knows that it's been modified. I do a git add period to add that to the stage. It's now showing changes that will be committed. And then I run git commit again to commit this change. Switched to uppercase.
Correctly spelled git.
Now we've got 2 snapshots that have been taken of our working directory that are in the repository. It even gives you a little summary of what happened. So one file changed, there was an insertion, there was a deletion. Bless you. Checking my
Is
pace card.
get spelled correctly, like GET? Is that a command already?
I don't know. What happens if you type GET?
Because I'm trying to figure out why they would name it.
Nope.
Git, I believe, I have to check this, but I believe Git is a word for like, it's like an English word for idiot or something like that.
Yeah, GIT
He's
is
a git.
an English word for an idiot.
Yeah, so that's what the thing is.
There's W get.
It's a stupid content tracker. So it's just a Git.
But apparently there are 60 other commands that contain GET in that order.
Apparently. All right. Git status shows that my working directory is clean. We like clean working directories, but that means we're not doing anything. All right. Now, I don't know where you've got your code that calculates the average, standard deviation, and all that stuff stored, but what I'm going to do is I'm going to copy my average script into this directory. And I'm going to start using this Git repository to track these command line filters that we've been writing to do things like calculate the average, the standard deviation, uncertainty. So I copy the average script in. Here's my average script. It's a little more, it's got a little more to it than what the one that I wrote in class. What I wanted to do was have the ability to, if I had a stream of data that came in that had more than one column, I wanted to be able to average each of those columns. So it's just using some arrays to keep track of an average for every column. And then the other thing it does is if the text that's found in a column doesn't convert to a number, like for example, if it's actually just text and if like a comment or something is in the stream, then it gets skipped. So anything that can't be converted into a number doesn't cause an error, it just gets skipped over. So that's all that this average script is doing. If I do git status, it says that there's an untracked file. That untracked file is the one that I just added. So in order to add it to the repository, I have to first stage it. So I do a git add period. And then I check to make sure that it was staged, and then I commit it. Now there's a shorthand that I use almost 90% of the time, I would say, which is that if your git commit message is very short, you can actually just put the message in an option to the git commit command, and the option name is TACM. So TACM and a string, you got to quote this so that those spaces will be passed in as the argument to that option. But TACM and a string will take and put the commit message in there automatically. So it won't open up Nano for you to edit it. It will just put that message in there. One file changed. There were 27 insertions. Now I have a clean working directory. All right, so I'm going to bring in some other stuff. Let's do the standard deviation directory, or the standard deviation script. This would be perfect for you, Doran, since you're pretty sure that thing doesn't calculate the standard deviation correctly. So you put it in here, then you start making changes till you get it to work. Then you put a commit message that says finally fixed standard deviation script. This again does the standard deviation over multiple columns. And it also calculates the standard deviation in one pass. So I don't have to read every line into an array and then go back through the array to calculate the average, and then go back through the array again to calculate what the standard deviation is. There's an algorithm that you can update the standard deviation calculation in place, and that's what this one implements. I've added one file. Add that to the stage so that it will be committed. Check that it has been added, and commit that with a message.
And I wish that my files had a more uniform naming convention because it would make it a lot easier to move all of them at once.
Yeah.
Because all the .py is, I just start .py, move it all done, and then it's like, okay, now I'm going to manually do square, manually do square, manually do manually do and that.
Yep. I'm sure you'll adopt some naming convention that addresses that in the future.
Should just change them. Because the reason why they have different naming conventions because I took them from the homework previously.
All right, clean working directory. Now I'm going to make a directory that tests or contains stuff in here so that I can test these scripts. So this is a common convention as well. I have a directory that's my repository. It contains some programs. I want to be able to test these programs. I want to keep the things that I use to test the programs with the programs. So I'm going to save those in the repository. So I'm going to make a directory called testing. I'm going to go into the testing directory. And then I'm going to create a data file. I'm going to create a data file that I could calculate the average and standard deviation of the numbers in the data file by hand if I needed to, right? So it's going to be very short, but it's just going to be enough that I can send the data to my average script and check that it's actually calculating the average correctly. So I'm just going to put 3 lines in here, 1, 3, 5. All right, so the average should be 3. The standard deviation should be, if I go through every one of these and subtract them from the average and then square it, add that all up together, divide by n-1, that should be the standard deviation. But there's only 3 things. I know the average is 3, so I should be able to go through and do that by hand to check this is actually working. So I'm going to save this data file, and then I'm going to check to make sure my average script works. So I used the file input module for Python, which means that it should work as either given the file name as an argument, or if I send the script some standard input, it should work for that as well. I mean, it should work just like the head and the cat command do in terms of if you give them a file, they'll use that file for input. Otherwise, they will read standard input for input. And my average script says that the average is 3. That's good. That's what I expect. I can also just cat that data file and pipe it to my average script. I still have to give the relative path name when I use this pipe though. The average script is in a directory above the directory that I'm in currently. And that returns 3 as well, so that works. Standard deviation, what should that be? So it should be 1 minus 3 squared, which will be 2. So I should have a 4 plus another 4 divided by 2. So it should be 8 over 2, which should be 4. And then I'm going to take the square root of that. So I think the standard deviation should be 2. Standard deviation script works whenever I give it the file name as an argument, and it works when I pipe data to it. Now I can at least feel semi-confident that it is calculating these things correctly. All right, let's go back up into the main directory. I run git status and it tells me that there's an untracked file, which is actually a directory. I want to add that directory. So that I can commit it. So now the data that I used for testing and this testing directory are going to be saved in my Git repository. All right. Git status tells me I've got a clean working directory. So everything went in there fine. Now I've got, God, what is that? Is that the 3rd commit or the 4th commit? Maybe the 5th. So it was like first hello world is 1. Then we modified that was 2. Then we added the average script. Then we added the standard deviation script. Now I've added the testing directory. So that's 5. All right, now that hello.py script, which we put in there just to sort of demonstrate that how to initialize a Git repository and everything, that thing's not really useful anymore because this is turning into a repository that stores our analysis scripts for the command line. So let's just delete that file. If I had something in there that I was worried about, maybe I'm gonna need that later, maybe I shouldn't delete it, just go ahead and delete it. You can always extract it from the repository later. Right? That file content is stored in the repository. So when I do a git status now after I've deleted something, it tells me that I've got changes that have not been staged. This time it's a deleted file. And then it also tells me how I could get that file back if I wanted. Like if I deleted this by accident, then git checkouts, double tack, the name of the file would extract that back from the repository. In fact, let's just try that. So I've just deleted hello world.py. I realized that that is not the file I was looking for or trying to delete. I was trying to delete a different file. Then I do a git checkout. So checkout means checkout from the repository. Now that file is back and has the same content that it had before. And then git status tells me that my working directory is clean. So let's remove it. Let's add that change. Check the status. I now have one thing to be committed to the repository. That's the deletion of a file. And I commit it just as I normally would. One of the novel things about Git when it first came out was that it can track file renames. So even if you rename a file, and it doesn't do this explicitly, but it can sort of tell that this file has the same content this file that no longer exists had, and it can detect that you actually just renamed the file. What's up, Corey?
I just heard a girl was up there. I just could not hear.
Yeah.
Sounds awful.
4 days problems.
Tell you what.
All right. I'm going to make a change to the average script that is not, well, I'm going to make a change that ends up breaking the average script. Okay, so I'm going to be worried about, I had it working, it doesn't work anymore. I could, of course, just type undo, undo, undo right now. But let's say that I made some change that I thought was going to work, and then it turns out that it doesn't work. So I've made a change here. I just deleted a couple of lines. And so if I try to run this, it's going to complain that something isn't defined. So I tried to run the average script on the testing data, and I get a failure. So it's, the delim is not defined. So I can't open up VI and do the undo command anymore, right? Because I've already closed it. That's already saved. So the checkout command is still there to save my ass here. So I look and see that the average script was modified. I can even see what was modified. So if I want to know, well, did I change something that I didn't realize I was changing? Git diff will print out line by line the things that changed. And so these red lines indicate that these things were deleted. So I deleted a blank line. This delim is equal to a space, and sum is equal to list. So I deleted a couple of variable definitions is what happened. And then I can do git checkout average to undo that. I now have a clean working directory. So you're always, you know, the more often you commit, the better safety net you're going to have. It's absolutely trivial and cheap to commit changes. So make a change that's important, commit it to the repository. Make a change that's important, commit it to the repository. You can always roll back as long as you've got a snapshot to roll back to.
So after you make a change, do you need to re-add the file, or can you just commit
After you make a change, like
to an
which,
existing file?
yeah, you need to add that file. Yep.
Okay.
So you're adding the changes to that file to be committed. Yep. So you got to do a git add period after every change. Now, if I run git diff, it prints nothing. So there's no difference between my working directory and the last snapshot that is stored in the repository.
Does git let you stack commands so you can do like add period, then like comma, then
No.
check?
No, you just do semi. If you want to do a bunch at once, just use a semicolon. So you could do git add period, semicolon, git commit.
Yeah, that's what I was asking. I just can't remember what the delimiter there was.
But that's bash. That's not git.
Yeah.
Git. It's not git allowing you to do that. It's bash. All right, let's look at the repository. So there's a program called GitK that will view a repository for you. If you do not have GitK installed, then just install it. It should tell you how to install it. I believe it's just GitK, so it's like a apt install GitK. So you run GitK inside of a Git repository, and it gives you a view of the history of your repository. So this is all information that is being stored every time you commit something to your repository. In the top left here is a little graphic that indicates the commits that you've made, and then the little message that you typed in for each one of those. So here's my initial import, switched uppercase, added the average script. Right below that is the diff. So that this tells you everything that changed from the previous snapshots to the snapshot that was just committed. And then all of this information, here's why it wanted our email address and username, so that we could put that information in the git commit messages if we wanted. So if we were working on a project with somebody else and we wanted to have documentation of who made this commit, it also tells you at what time that commit occurred. So this is 1411, 1408. It's got information in there that is just useful for the Git internals, but basically every commit that you make gets a hash associated with it. It's basically a hash of the commit object. So this long 40-character string corresponds to a specific snapshot. The nice thing is that 40-character string is mostly, I mean, we're never going to run into a collision, is unique. So all of the snapshots in your repository have a unique 40-character number that Git uses to keep track of them. So it's very easy to tell if two things are the exact same or not by comparing their 40-character hash ID to each other.
Yeah, when you have 36 options for the characters, that tends to give you quite a few.
It turns out to be huge. Now this is I don't know what the algorithm is, but these algorithms can be sort of broken so that you can get two different files that would hash to the same number, but I haven't heard that being a problem here. So this is called GitK, and it's a way for you to just go through and sort of view the stuff that's happened. When we start making branches, this little cartoon here will show things like, well, now you have two versions that sort of diverged from each other. You started making changes, and then you can merge those back, and it'll show you a graphic of them merging back. Yes, Tyler?
See, if you have, it's like 1.69 times 10 to the 60-second files, then you're just gonna run out of hashes.
Yeah.
So, I mean, it's a pretty big block.
Yeah.
So start a new repository when you hit the times 10 to the 60.
Yeah. That's all you need to do.
Here's how you would install it, which I've already done.
I'm certain that by the time you generate that many files, they will have added additional characters to it.
Or you could put all of those into a directory, and then you start a new one.
Let's see, is there anything else nice in here? Nope, I think this is all for now. All right, so that's our first repository. We're gonna continue using Git next time. Make some changes. What are we gonna do? We viewed it. Oh yeah, we're gonna clone repositories. So what if I want to make a copy of a repository, either to put on a local machine or just to make a copy of? How do I get copies of repositories that are stored online? So like, how do I clone a repository from GitHub and use a project that's posted on GitHub? We'll pick that up on, let's say, Wednesday, Friday. Thanks for joining us, Corey.
If we put